Hello, everyone. How are you doing? I trust you're all doing great. James from JTS Maths Tutoring here. Today, we are going to be looking at a linear system, and we want to determine the type of solutions that this linear system has without us working out the system. So to demonstrate this concept, we have borrowed a question from Unisa Linear Algebra I, assignment 6, question 4. So let's get going. Solve the following linear system. The values of x for which the system has no solution, exactly one solution, infinitely many solutions, is or are. Right, let's get going. First things first, we can see that the system is actually in an augmented matrix form. So we need to check if this augmented matrix is in either row echelon form or reduced row echelon form. If not, we have to convert it to either row echelon form or reduced row echelon form. So we can actually see, we can clearly see that this is not in row echelon form, let alone reduced row echelon form. So that's the very first thing that we are going to do right there. Then afterwards, we are going to use the last row of the reduced row echelon form or row echelon form to determine the type of solution. All right. So here we call upon Gauss or Gauss-Jordan elimination to help us achieve that. Right. I already have my leading one where it is supposed to be, so I need to have this one here to be a 0 right here. Okay, so what am I going to do? Minus row 1 plus row 2, which is exactly what we have right here. So minus 1 plus 1 is going to give us a 0 right here. Then minus this, you add it to what we have right here, it's going to give us minus 2x squared minus 2. Minus this whole thing here, plus this is going to give us x squared minus x minus 8. Minus this, what we have right here, add it to this 3 here, it's going to give us an x right here. Okay, beautiful. So we have our 0 where we want it to be. Our next thing is that for it to be in row echelon form, which means you're actually converting it to upper triangular form, we just need to have a 0 right here. And once we have the 0 right there, boom, we can do whatever we want to do now. There's no need for us to go all the way. All right, beautiful. So minus row 2 plus 2 row 3 to give us a new row 3. Okay, beautiful. Okay, minus 1 here by 0 is going to give us a 0. 0 plus 0, boom, you're going to have it exactly what we have right here. Okay, then if we have minus row 2 here plus 2 row 3, it's going to give us a 0 right here. Minus this row here plus 2, this row is going to give us x squared minus 6 minus x. All right. Minus x here plus 2x is just going to give us the x. So I'm going to stop right here. And now for us to be able now to determine the type of, and this is how the last row is supposed to look like for this system to have no solution. All right, so which means right here we are supposed to have a 0, and where we have this x here, we must have any other number apart from 0. Okay, so solving this x squared minus x minus 6 is equal to 0. Obviously, this can be factored out. So I'm going to have x plus 2 multiplied by x minus 3, which is going to give me x is equal to 3 or x is equal to minus 2. All right, we must have any number which is not what? 0. So x can be 3 here, x can be minus 2 here, x can be anything else here. So I know that if I plug in 3 right here, I'm going to get a 0 here. So which means 0 is equal to 3, which is a contradictory statement. It's not true, hence no solution. Assuming that x is equal to minus 2, this is going to have a 0 right here. I'm going to have a minus 2 right here. So 0 is equal to minus 2 is to a contradictory statement. So what this means is that for this system to have no solution or for it to be inconsistent, x is equal to 3 or x is equal to minus 2. Beautiful. And for this system to have exactly one solution or to have a unique solution, the last row is supposed to look like this. So which means this one is not supposed to be equal to 0. This one is not supposed to be equal to 0. But we already know that if we solve for this, we're going to get x is equal to 3 and x is equal to 2. So which means x is not supposed to be equal to minus 2. X is not supposed to be equal to 3. for this to have exactly one solution. So what does that mean? It means that X can assume any number from the real number system as long as that number is not equal to 3 or -2. Beautiful. Awesome stuff. Let's go to infinitely many solutions. So for it to have infinitely many solutions, this entire last row must be full of zeros. And we know it will have a 0 here when x is equal to 3 or when x is equal to -2. But when that is the situation, you can tell that this part here cannot be equal to 0. All right? So we can actually see here that in our last row here, this last row, this entry right here, after the argument, it will never be 0 when x is equal to 3 or when x is equal to -2. Therefore, we conclude that there are no values for x for this system to have infinitely many solutions. Boom. There we are. Did you see that, Jimmy? You threw that miles away. Guys, this is all I had for you today. Allow me to do what my mama taught me. Mama always teaches me that a good visitor knows when to leave, or mama would say a good dancer knows when to leave the dance floor. So right now, allow me to leave. Adios, amigas and amigos. But until we meet again, be rest assured at JTS Maths Tutoring, we are committed to keeping you mathematically informed. See you soon.